Electronic configuration, atomic structure assignment we are discussing. We will discuss maximum questions related to electronic configuration with detailed discussion. Have patience. Stay here for 15-20 minutes. We will be getting maximum questions here. All these are useful for your JE main as well as NEET examination. Even useful for your board exams also. Fine. Chalo. Let's start. Electronic configuration. No two electrons in an orbital can have parallel spin. This statement emerges from Pauli's principle, right? Pauli's exclusion principle says no two electrons can have same set of quantum numbers. Aubau's principle says first electron enters into lowest energy orbital. Hund's rule says pairing of electron takes place only after filling the all orbitals with one electron each, which are degenerated. Degenerated means equal energy. So here 166, option 3. Electrons never pair if there are empty orbitals in a given subshell. This is only called Hund's rule. So we'll go to Hund's rule here. Yes. Heisenberg's uncertainty principle is known to you? Right. Heisenberg's uncertainty principle is it is impossible to determine the exact position and exact momentum of subatomic particles like electron. Which of the following explains the sequence of filling electrons in different subshells, that is Aubau's principle? First 1s orbital, then 2s orbital, then 2p orbital, so on. Nitrogen atom has 3 unpaired electrons in its ground state. It can be explained by Hund's rule. How? See, this is p subshell. When 3 orbitals are there, we have to fill one by one. So this is explained by Hund's rule. The electronic configuration of sodium is, sodium atomic number is 11. So neon, if you take neon is 10 plus 2, it will become 12. Neon is 10, 1, 11. So this is your right answer. And this is for potassium, this is for calcium, this is for magnesium. Which of the following configuration may represent the ground state of nitrogen atom? Just now you have seen all these electrons must be with same spin. Don't show like this. Electronic configuration of the element with atomic number 56 and mass number 138 is 54 is xenon. Okay, then 2 electrons are entering, so that is 6s2. 54 is for xenon plus 2 electrons. Krypton is 36. Got it? The electronic configuration of boron cannot be 1s2, 2s3, right? Because 2s orbital can accommodate maximum of 2 electrons. No 2 electrons in an atom can have the same set of 4 quantum numbers exactly. Because if you want to give 2s3 like this, impossible, impossible, impossible. But if you are giving like this, spin quantum number plus of, spin quantum number minus of, for this spin quantum number should begin either plus of or minus of again. No 2 electrons can have same set of all 4 quantum numbers. So it is just impossible. Both statements are correct and correct explanation. The correct valence electronic configuration for copper, Z is equals to 29 is. Copper electronic configuration is well known to you. 4s1 3d10 because of full filled stability. Which one of the following pairs of ions have the same electronic configuration? We'll go this side, same electronic configuration, configuration. Okay, so which one is best? See, iron atomic number is 26, 3 gram. So it will be having 23 electrons. Manganese 25, 2 gram. So they must have same. Correct? When 2 different atoms with same oxidation state can never have same number of electrons. Logic. The n plus L value for 4f subshell is n plus L. N is 4. L value is 3. So 4 plus 3 is equals to 7. L is equals to 0. S orbital. 1 p orbital. 2 d orbital. 3 f orbital. The energy of the electron in the hydrogen atom depends on the principal quantum number only. For hydrogen, this is very, very special. 1s, 2s equal to 2p, 3s equal to 3p equal to 3d, 4s equal to 4p, so on. Got it? This is exclusively for hydrogen. IEEE question long back. After 3d sublevel is completely filled, the differentiating electron enters into the level. After 3d sublevel completely filled, the differentiating electron enters into the sublevel. See, first 1s, then 2s, 2p, 3s, 3p, 4s, 3d, then 4p. The electron will be entering into 4p orbital. First 4s, then 3d, then 4p. Okay, don't confuse. The correct ground state electronic configuration of chromium atom is atomic number 24, argon 3d54s1, half filled stability. The configuration of 1s2, 2s2, 2p6, 3s2, 3p3 corresponds to, see, 2 plus 2 plus 6, 10 plus 2 plus 3, total 15. 15 is for phosphorus. The configuration 1s2, 2s1, 2px1, 2py1, 2pz1. Okay, now this is 2pz. 2pz1 represents. Okay, now this is actually total number of electrons are 1. There are 6 electrons are there, 2 plus 1 plus 1 plus 1. 6 electrons are there, so that must be carbon atom, but not in the ground state. If it is in the ground state, it cannot be 1, it should be 2. So excited carbon atom. The total number of p electrons present in the phosphorus atom is 1s2, it is not p electron, 2s2, it is not p electron, 2p6, yes, these are the p electrons, 3s2, no, 3p3, p electrons. So 6 and 3 total 9 p electrons are there. 9 p electrons means p orbital electrons. The valence electron configuration of an element with atomic number 23 is vanadium. Okay, now 4s2, 3d3. For few elements here, except chromium and copper, you can write like this. 23, na? Like this you write down. Here you write 4s, here you write 3d. Okay, except chromium and copper, it works. It works, right? Magnesium plus 2 and aluminum plus 3 have same electrons, so it is said to be isoelectronic. When the number of electrons are same, obviously electronic configuration will be same. The number of unpaired electrons in the valence shell of silicon is 1s2, 2s2, 2p6, 3s2, 3p2. Number of valence unpaired electrons are 2. Right? Silicon atomic number is 14. An orbital can't have more than 2 electrons. The first 2 electrons in a p subshell are having different magnetic quantum numbers. So obviously both are right, but there is no proper reason. That is not a proper reason. There is no proper explanation. Which of the following electronic configuration corresponds to an inert gas? Inert gas means that must be completely filled. And here you see, this is of neon. Neon is an inert gas. Helium, neon, argon, krypton, xenon, and radon. The reason for chromium to have 3d5 instead of 3d4 is more exchange energies. क्या होता है exchange energy? See here. 1, 2, 3, 4. 1, 2, 3, 4. If 4 unpaired electrons are there, what happens? It can be exchanged with all these 3. This can be exchanged with these 2. And this can be exchanged with this one. And if you are taking, so 6 exchanges are possible. And if you are taking D5 configuration, it can be exchanged like this. 1, 2, 3, 4. Exchange is very simple, man. You change your TV from hall to bedroom. Okay, now. Exchange means there must be TV in bedroom also. Exchange. You are not bringing here. You are just taking from here to there. Okay. So the reason for chromium to have argon 3d54s1 is more exchanges. More exchanges. Here in case of 3d5 configuration, there will be 10 exchanges possible. 10 exchanges. Next, which of the following configuration is not possible? Okay, now 3f7, because f orbital starts from 4th level. 3f7 is impossible set. Why? Because f value will be if you see F orbital, here n is equals to 3 and F orbital L value is also 3. This is impossible. N and L cannot have same values. That means L is always starts from 0, 1, 2, 3 up to n minus 1. L cannot be equal to n. So that is impossible set. Which of the following ions is not isoelectronic with O minus 2? O minus 2 means 8 plus 2, 10 electrons. Nitrogen 7 plus 3, 10 electrons. Fluorine 9 plus 1, 10 electrons. Titanium atomic number is 22, plus 1 means minus 1, so 21 electrons, not at all related. Sodium 11 minus 1 is equals to 10 electrons. Number of valence electrons in carbon is, carbon atomic number is 6, 1s2, 2s2, 2p2. So these 4 are the valence electrons. The number of unpaired electrons in Fe plus 3 is, iron atomic number is 26, so electronic configuration will be argon. Argon means 18 gone, 4s2, 3d6. But Fe plus 3 means 3 electrons to go. When 3 electrons are going, electrons first removed from the s orbital because s is outside. So argon, 4s is 0, 2 gone, and 1 should be removed from 3d orbital, 3d5. When 3d5 is there, 1, 2, 3, 4, 5. There are 5 unpaired electrons. 5 unpaired electrons. The number of unpaired electrons in 1s2, 2s2, 2p3. 2p3 means there are 3 unpaired electrons. 1, 2, 3. This gives a lot of practice, these kind of questions. In potassium, the order of energy levels is 4s is lesser energy than 3d. This is the right one. The number of d electrons retained in Fe plus 2. Number of d electrons retained in Fe plus 2. Just now we have seen iron atomic number is 26. That is argon. Okay, 4s2, 3d6. When you are saying iron plus 2, electrons first removed from s orbital. So it will become 4s0, 3d6. Means all the 6 electrons are retained. All the 6 electrons are as it is. Coming to 196. Which of the following is the correct electronic configuration of Fe plus 3? And just now we have seen 3d5. 3d5, 3d5, 3d5. 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. 3 electrons gone. The configuration of chromium atom in ground state is, this is also just now we have seen argon 3d5, 4s1. The number of unpaired electrons in 1s2, 2s2, 2p3 is, the number of unpaired electrons in 1s2, 2s2, 2p3. This question is also repeated. Just now we have seen 3 electrons, 1, 2, 3. Number of unpaired electrons in the electronic configuration of 1s2, 2s2, 2p4. You see CBSE means you'll be getting regular. 2p4 means beta 1, 2, 1, 2, 3, 4. P orbital will be having 3 subshells and number of unpaired electrons are going to be 2. This fundamental particles exercise 2 will make in another video. Thank you. This is your Lakshma Reddy sir. If you really like this video, share with your friends.